Separable differential equations. When given a differential equation with two variables, you must separate the variables before you can integrate, solve for c, and solve for y. Oftentimes in FRQs, separable differential equation problems include slope fields. Slope fields are visual representations of the derivative at certain points. They are solved graphically, whereas separable differential equations are solved analytically, or otherwise known numerically. The derivative of an equation gives you the slope. So, to plot the slope at each point on the graph, plug each coordinate into the derivative given.
Slope field!
Consider the differential equation dy dx equals x plus 1 times y.
On the axis provided, sketch a slope field for the given differential equation at the 9 points indicated.
First, with the slope field, plug the given x and y values of the points on the graph into the equation to get the slope of the equation at that point.
Next, take the slopes you solved for and plot them onto the graph.
Don't forget, the greater the slope, the steeper the line.
Tangent line!
Write an equation for the line tangent to the point 0, 3. Use the equation to approximate f of 0.5.
First, plug the point 0, 3 into the equation, then solve for dy dx, or the slope.
When you plug in the point 0, 3, the slope equals 3.
Then plug the point and the slope into point slope form.
Using point slope form, plug in the point 0, 3 and a slope of 3 to solve for the equation of the line.
Now, find f of 0.5. When you plug 0.5 into the equation, you get 4.5.
Separable differential equation.
Find the particular solution y equals f of x to the differential equation with the initial condition f of 0 equals 3.
Step 1. Separate the variables, then move the y term with dy and the x term with dx. Cross multiply.
Step 2. Integrate both sides.
After the previous step, take the integral.
Don't forget to add c, but only to one side, because otherwise they will cancel out.
Step 3. Solve for c using your initial condition or your ordered pair given in the problem.
C equals the natural log of the absolute value of 3.
Step 4. Plug c back into the antiderivative to solve for y. After plugging in c to solve for y, you must use e to simplify the natural log.
Step 5. Simplify, then choose positive or negative.
When simplifying a problem that includes an absolute value, you must introduce both signs. In this case, when you plug the initial condition into the equation, it is positive. Therefore, the answer must be positive.